Today we're looking at parallelograms and how we are able to do either different coordinate proofs or regular proofs with these figures. So before we can actually do those, I think it's important that we understand what the definition of the parallelogram is and the different properties that it possesses. So our basic definition of a parallelogram is a quadrilateral, so a four-sided figure, with two sets of opposite sides that are parallel. Okay, so properties that come with that. First property is just that we get two sets of opposite sides that are parallel. We also have two sets of opposite sides that are congruent, meaning same distance, same length. We're also going to find that they have opposite angles that are congruent. And lastly, we're going to find that the diagonals bisect each other. So using that information, we are going to prove down here, we're going to do a proof, a two-column fill-in-the-blank proof. And we're going to see, first off, we have a quadrilateral, has opposite sides that are congruent. And we are going to prove, with just the fact that it has opposite sides congruent, so that's property number 2, that it has to be a parallelogram. Okay, so our first thing is our given. Our given is simply stating we have a four-sided figure where I have opposite sides that are in fact congruent. Looking at number 2, saying HF is congruent to itself, well, that's your reflexive property. And if I look at those triangles, we can say, well, they've got to be congruent right now because of side, side, side. So in our last unit, we said, okay, if triangles are congruent, well, then we know parts have to be congruent. So the parts we're specifically looking at here are angles 1 and 2, and then angles 3 and 4. We said, okay, if triangles are congruent, parts are congruent, that is CP, CTC. Corresponding parts of congruent triangles are congruent. So if I were to just focus in, let's say, for instance, on angles 1 and angle 2, I can see if they are congruent, which they are. And I were to trace out how they're formed, that sure looks like those lines have to be parallel. Well, that's because angles 1 and 2 are alternate interior angles. So we can say here, if our alternate interior angles are congruent, then the lines are parallel. And if we think about what we just found, we have a four-sided figure where we have two sets of opposite sides that are parallel. We've got to be able to state that it's a parallelogram. And really, that's a definition of a parallelogram. You can explain that by saying a quadrilateral with two sets of opposite sides parallel is a parallelogram. So that was proving one of the properties. That was property number 2. We're going to take a look on the back side, and we're going to prove property number 3, the fact that opposite angles are congruent. So again, we're starting off with the fact that we have a parallelogram. So that's our given information. We already know that we have a four-sided figure, that in fact it is a parallelogram. So knowing it's a parallelogram, we're able to state the fact that, well, then opposite sides have to be parallel, because that's a property. So we can just explain opposite sides of a parallelogram are parallel. So again, going back to this, kind of like we did before, well, knowing that the sides are parallel, if I take a look at those two lines, and I cut it by a transversal, again, we're going to find things like angle 1 and angle 2 being congruent. And if I switched my lines I could find things over here, and again, take that transversal. Now that's going to show me angle 3 and angle 4 are congruent. And looking at those pictures, those again are alternate interior angles. So we can say here, if, we'll say it a different way. How about that? Alternate interior angles are congruent when your lines are parallel. Then we have our property that BD is congruent to BD, so there's a reflexive property. And now if we look at those triangles, kind of like we did in our last unit, we have 3 congruent statements. So that gives us the right to look at the triangles and say, how are they congruent? If I look here, I have an angle, side, angle. So for step 5, we can say angle, side, angle. And then for step 6, we were trying to prove opposite angles congruent. Opposite angles being like, for instance, angle A and angle C. Well, if our triangles are congruent, we know that the parts are congruent. So these are the parts. You can say down here then CPCTC, corresponding parts of congruent triangles are congruent. Notice if I really wanted to, I could also pick other parts, and I can show you that the opposite sides have to be congruent if it's a parallelogram, again by using CPCTC. And then our last proof that we're going to take a look at is a coordinate proof. These are kind of nice because what we need to do is do things like distance, midpoint, and slope. So the first thing I want to do is let's make sure we plot this out so we can see the shape. So we have a -3, +2. And please make sure once you plot them, you are also labeling them so that then we have an idea what the picture looks like. We get some ideas in our head of hopefully what our answer should be. And here's our shape. So with a nice straight line, we're going to connect these, and I can see here's my quadrilateral, it's my 4-sided figure. And I want to prove it's a parallelogram. So if it's a parallelogram by definition, I know opposite sides need to be parallel. If we're showing parallel, we want to think test slope. And if they're parallel, I should have opposite sides having the same slope. So we're going to start with AB and we're going to test the slope. So keep in mind we're thinking slope formula in your flip book in case you forgot. So for AB, if we plug this in, I have a -1 - 2. And for the x's, I have a -2 minus a -3. So minus a negative, remember that's plus a positive. So my numerator becomes a -3. The denominator becomes a +1. And this simplifies down to a -3. Now opposite of AB is CD. So if we take a look at CD and plug that into our slope formula, my numerator I would have 4 minus 1. The denominator, the x's, 3 minus 4. And if we simplify, I have 3 over -1. If I simplify that, that's also going to be a -3. So what I can see here is I have the same slope. So that means that I found one set of sides that are parallel. So now we have 2 more sides. We have sides AD and BC. And we hope that those are going to have the same slopes. So if I'm looking at AD, again, in my top, y2 minus y1, so I'd have 4 minus 2. And on the bottom, I'm going to have 3 minus a -3. So 4 minus 2, I'm going to get 2. 3 plus 3, we're going to have 6. We always want to reduce slopes. So we're going to have a slope of 1/3. So opposite of AD is BC. And now again, if they're parallel, they should have the same slope. So we're going to test slope of BC. So I have 1 minus a -1 on the top. And on the bottom, I'm going to have 4 minus a -2. Okay, so we simplify. So our numerator is 2. Our denominator is 6, and again, that's going to reduce down to 1/3. So that's good. We want that because now we can see, again, they have the same slope, so again, they're parallel. So our goal of this problem was to show it was a parallelogram, and we said we wanted to have two sets of opposite sides that were parallel. So the very last thing that we need to do is just come up with a concluding statement summarizing everything that we've just calculated. So we can say here, ABCD is a parallelogram because it is a quadrilateral with two sets of opposite sides that are parallel. So coordinate proofs, you always want to end with a concluding statement, just summarizing all of the calculations that you have done. We'll practice more of this in class and get into a little bit more of the coordinate proofs and how we use distance. Have a great day.